Have you ever thought about what it would really take to build an infinite digital world? I don't just mean a big one. I mean a world that just keeps generating forever as you explore it, and, this is the critical part, a world that actually remembers everything. It sounds like something straight out of science fiction, right? Well, a new AI model is making this a reality. So let's dive in and see how it works. Just imagine this for a second. You're walking through a world that looks just like this. You go down an alley, you turn a corner, and then you spend hours, maybe even weeks, exploring completely different parts of this world. Now, what happens when you decide to come back? What if that alley was exactly as you left it, down to the very last detail? That's the dream of a persistent, interactive world, and believe it or not, it's been incredibly hard to pull off. You see, for years, creating these kinds of worlds has been stuck behind this massive roadblock. It's a fundamental conflict, a trade-off that has always seemed just about impossible to solve. I'm talking about the constant battle between speed and memory. And here it is, that big trade-off. For a world to feel convincing, it needs real-time speed. When you press a button, the world has to react now, instantly. But at the same time, it needs long-term consistency. If you leave a room and come back, it's got to look identical. The whole problem is that AI models have always been good at one of these, or the other, but never, ever both. They were either super fast but had the memory of a goldfish, or they had a great memory but were way too slow to be interactive. This table really lays it all out crystal clear. Just look at the previous models. You can see that trade-off in action. Oasis, it was real-time, sure, but it had no long-term consistency. WorldMem, it had consistency, but it wasn't real-time. Up until now, no model could check both of those boxes, especially if you wanted a general-purpose world. You know, something beyond a specific game like Minecraft. Well, that's all about to change. A new system called WorldPlay has finally cracked the code. It's managed to achieve both the speed and the memory that we need for these incredible, persistent worlds. For starters, WorldPlay can generate these stunningly realistic environments, like this art gallery. It has a real understanding of light and shadows and complex geometry that just makes the whole scene feel completely believable. But it's not just stuck on photorealism. It can also create these highly stylized worlds with a totally unique artistic vibe, which shows you just how flexible it is. So it's not just about recreating our world, it can imagine entirely new ones. And of course, the big one, it can generate these huge, explorable game environments. This is where that combo of speed and memory becomes absolutely essential for creating the next generation of games. Okay, and here you can see that breakthrough in action. On the left, that's a scene the user is exploring. Then, after walking away, wandering around for a while, they come back to the exact same spot which you see on the right. It's identical. This is long-term consistency, and it's the magic ingredient that makes the world feel solid, real, and dependable. So, the big question is, how does it pull this off? Well, it all comes down to a few really clever innovations. The first couple are all about how it handles control and, more importantly, how it remembers. First up, it uses something called a dual action representation. Now, think of it like this. It gets the intuitive WASD keyboard commands that we all know. That's what gives it that natural feel. But at the very same time, it's also tracking the camera's exact coordinates, kind of like a GPS. This combination is genius because it gives you both that fluid control and the super precise location data it needs to recall a memory perfectly. To get a handle on its memory, let's use an analogy. Imagine the AI is keeping this magic scrapbook of every single place you visit. When you go back to a location, it doesn't try to redraw it from scratch. Nope. Instead, it just flips back to the right page in the scrapbook to remember exactly what it looked like. But how does it stop that scrapbook from getting too full or, forgetting the old pages? This is where the real magic happens with a technique called temporal reframing. Okay, so in step 1, the model makes a memory of a place. It adds a page to its scrapbook. Then step 2, you wander off and explore somewhere else. Now here's the trick in step 3. When you come back, the model doesn't just find the old memory. It literally pulls that memory forward in time, basically telling itself, hey, this memory is super important right now. In a nutshell, it's dynamically rewriting the timestamps on old memories to make them feel recent to the AI. This whole process cleverly prioritizes past information based on where you are now, which stops important memories from just fading away. It means a place you visited hours ago has just as much weight as a place you saw 2 seconds ago. It's a perfect memory that just doesn't degrade. Okay, so that explains the perfect memory. That's amazing. But what about the other half of the puzzle? How does WorldPlay do all of this while still being incredibly fast? And the answer is, it's very fast. WorldPlay is generating streaming 720p video at a buttery smooth 24 frames per second. That is true real-time performance, more than fast enough for seamless interactive fun. The secret to this speed is all in a clever AI training technique. And that technique is called distillation. It's a simple idea, but it's really powerful. You take a massive, powerful, but kind of slow AI, let's call it the teacher, and you use it to train a much smaller, faster AI, the student. The whole point is to get the student to produce the same amazing results as the teacher, but at a tiny fraction of the cost. But this approach led to a huge problem. See, standard teacher models are memoryless. They're trained on short little clips, and they have zero concept of long-term consistency. So how on earth could a teacher that has no memory teach a student how to remember? It was a complete mismatch. WorldPlay's third big innovation, context forcing, just completely solves this. They gave both the teacher and the student access to the exact same memory cache. By forcing them to share the same scrapbook, the student learns not just how to generate beautiful images quickly, but also how to use its memory to keep everything consistent. This alignment is the absolute key to finally getting both speed and memory in one package. So, a fast, interactive world model with a perfect memory. What does this actually mean for all of us? What kind of new doors does this technology swing wide open? Well, for one thing, because the model understands 3D space so deeply, it can reconstruct an entire 3D scene from just a single 2D image. It can turn a point cloud, like the one on the left, into a fully explorable world, like the one on the right. And these worlds aren't just static museum pieces. They are dynamic. They respond to simple text commands. In this case, a user just typed smoke spread, and boom, the model generates a dynamic smoke effect right in the scene. That level of interactivity just opens up a whole universe of creative control. So what this all adds up to is, well, we're looking at the start of next-gen video games, with worlds that are truly endless and persistent. We can build incredibly realistic simulators for training and research. It's a powerful new tool for artists and developers. And maybe the biggest deal of all, it's a huge step towards embodied AI. For an AI to really learn about cause and effect, it needs a consistent world where actions have predictable results. A world that never forgets is basically the perfect digital classroom. This technology literally hands us the tools to build digital universes that aren't just infinite, but also have a perfect, unfailing memory. It solves a problem that developers have been tearing their hair out over for decades. So really, the only question left is, with the power to create any world we can possibly imagine, what are we going to create first?